So this is a more complicated question. So I'm going to go through this one particularly, and that's because I know all the resistances, but I have two uh, sections that are in parallel, but then those parallel sections are in series. So I'm going to start by finding the resistance of this section. So if I find the resistance of this section, then I have to use my parallel equation. So 1 over 60 plus 1 over 10, or 12, sorry, I apologize. So I'm going to put that in my calculator, 1 divided by 60 plus 1 divided by 12, and I'm going to invert it, and I ended up with 10 ohms. So that's what I've done for the red section. Then I'm going to do the same thing for down here. I'll just do it in blue so it's easy to follow. And in this one, I'm going to do the same thing. I'm going to say 1 over 11 plus 1 over 22 plus 1 over 33. Now, this part should have been pretty straightforward because we did questions like this already, but there is a trick to this question. So then I'm going to invert this and find my answer. So I got 6. So this section's 6 ohms. Now, if I think about this, the red section is then in series with the blue section because everything goes through the red section and then everything goes through the blue section. So I just add those together, which gives me a total over here of 16 ohms. This is helpful because now I can use Ohm's law, V equals IR, to find the current. So 72 divided by 16, and I'm going to get 4.5 amps when I do that. Okay, why is this important? Well, because that 4.5 amps is going to go through the red section. If I just consider it as an area, some of it will go through the top and some of it will go through the bottom, but it will all go through there. What that means is if I consider this red section as a section and consider Ohm's law for the section, I know that all of the current passes through it and all of that current experiences a total resistance of 10 ohms, which gives me 45 volts as my potential difference. That means the bottom one is 45 volts and the top one is 45 volts because it doesn't matter which one it goes through because they're in parallel, right? It doesn't matter which one it goes through. Both of them will be the same number. So 45 and 45. This now lets me find my current because I can now use V equals IR again, right? Ohm's law. So I can say 45 divided by 60, which is 0.075. And then I can say 45 divided by 12, which should be the remainder of the current. And mathematically it works out because these two currents should not only work out using V equals IR, but I also know that this plus this should equal 4.5, which it does. I'm going to do the same thing for the bottom, right? Same thing, I'm going to think about the blue section as one entity. If I think about it as one entity, then I can find its potential difference, which means all of the current goes through and it experiences that 6, so 4.5 times 6, so I get 27. Now, this also makes sense because 27 plus 45 gives me my total of 72, which I should get, right? So that is very logical. And then I can just use Ohm's law to find all three of these. Now remember, these three currents will also add to, when they add together, all three of them, I should also end up with a total of 4.5 amps. So 27 then divided by 22. So I get 1 point. Now there is some rounding, so you might be off by a decimal place. Don't get too excited about that, right? Because we are rounding. These are not going to give me perfect numbers. And 0.82. And if I go 2.45,